keyboards.
Yeah. I remember when I was first learning, like it, I wouldn't have been able to type so fast.
Yeah, sure.
Because I've been using Vim for a little bit already, so I can just figure out what I want to do, and then it just becomes easy. But it takes practice.
It's on my to-do list to go and get my Vim skills up there. I only know the basics of Vim.
Are we starting?
Right.
Oh, hello. We got 20 people in here now. Give me a moment. I'm going to. Is this working? Hello. Okay. I'm going to grab the participants in chat. Just put them off to the side so I can see anything that pops up. Okay. All right. Hello. Welcome to Should Ignite. What is this? Yeah, session 1, or yeah, session 1, excluding yesterday's session. So just a quick sort of disclaimer. Again, if you missed the last session, we are recording all of these. So all of these are recorded, and screenshots from the sessions can be used in sort of like social media and things like that. So if you do turn your camera on or unmute yourself at any point during the session, you are giving us permission to use those clips for our own sort of promotional stuff. However, the breakout rooms, which we'll go into, I think there'll be 2 sessions where we go into breakout rooms today, those will not be recorded. So you feel free to unmute, turn your camera on, whatever. If you missed the last session, all we went over was sort of introductions, and then we kind of got into how to install Python, install VS Code, and then install Pygame. So if you missed all of those, go back and watch the previous video. Just ask your mentors, and they have the link to it. Otherwise, we're going to get started with how to use sort of we're going to start with a review first of all of just sort of Python things in case you forgot, and then we're going to get into actually doing a bit of exercises and some Pygame stuff. So let's get started. So quick overview, we're going to just review variables, if else, lists, for loops, functions, things like that. Very, very quickly, we're going to talk about tuples, this dot operator, and then we're going to introduce you guys to Pygame, and we're going to have some sort of fun. So once again, this is going to be very quick. There are slides that you can come and review later. So let's get started. If else statements. So in case you forgot, these are used to sort of program logic into your programs. So you can see there's this little tree diagram where if one condition is met, you go in one path. If another condition is met, you go down another. So in this case, if it's raining, we go down this first path, which is we print our umbrella, right? So if it's true, we print the umbrella. If it's false, we say, have a nice day. Additionally, we can chain multiple if-else statements together. And so this is going to look something like that, where we have this first thing. So we have a first condition. If this is true, then we print and we stop. This second condition, we print and we stop, right? And then we kind of keep going. If once every condition fails, then we check the next one, then we check the next one until we hit the last case, which is sort of like our sort of default case if everything fails. All right, so one thing to remember is you also have sort of assignment versus equality. These are 2 very different operations. So equality has double equals. This will check if 2 things are equal, right? So it checks if 2 numbers are the same, or if it checks if 2 strings have the same amount of words, right? Or same characters. And then the assignment is you're setting a variable to some sort of data. So here we're setting x to 3, this fruit is a banana, right? So the equality, it can be used in these sort of conditions that you put into your if. Assignments can't. So you would want to use the double equals if you want to check for equality, not an equals. So this is the first quick question worth 10 points. So if you missed the first session, we have points that you get for answering certain questions. This is the first one. So what is this going to print? We have some variables, and we have a bunch of if statements. What is going to be the output in your thing in this program? So I think there's a poll out right now. You can go ahead and answer that one. And I don't think I can see the results of it.
Oh, yeah, I can make you co-host. Just give me a second.
Let's see. I see it. Thank you. Okay. So who responded? Okay. Okay, we're getting some. So I'm seeing, so pretty much everybody sees that less than 20 is going to be printed. A few of you are also saying that greater than 0 is going to be printed. So yeah, so what was the last option was less than 20 and greater than 0. And the second one, which was the second most picked, is going to be just less than 20. So let's just go over this really quickly. So we're checking our number is 4, value is 5, our result, number times value, that's going to be 4 times 5 is 20, divided by 2 is 10, right? Quick maths, plus 4 is going to be 14. So we have a 14 in our result. And then that is less than 20, obviously. But then also notice that we don't actually have an else if here. We don't have an elif. So even though that this is less than 20, this if statement is still going to run. So this if statement is still going to be checked, even though this one already was correct. So it is true that 14 is less than 20 and greater than 0. So this will run, and then this second statement is going to run as well. Right? So if we had an elif here, then less than 20 would be correct. But since we don't have an elif here, we also have to check it once again, right? So yeah, 53%, it was about split on that one. 53% managed to get it. So we're going to move on. Very quickly of lists. This lets us keep sort of multiple values in one single variable. So we can have, this is a list of numbers, right? And the index list starting from 0. So the first index is 3, right? Second, or the 0th index, I think that's the better way to say it, is going to be 3. The first is going to be 5. Second is 6. So a good rule of thumb is the last element is going to be the length of the array or the length of the list minus 1. So here this has there's 4 values in our list. So the final index is going to be 4 minus 1, right? Another thing to kind of keep in mind is lists can contain anything. So they can have numbers, strings, decimal numbers, true, false values inside of them. But yeah, so that's something to also keep in mind that you might want to use in your own programs, might come in handy. And here's a quick cheat sheet. We can get the length of a list using this length function. We can also add to a list using this append method or function. So we can, this will add, so we have ABC, right? We can add D to the end. And after we added D, we can also use remove to take out B, right? And we can also just completely clear the list. So these are 4 really good things to kind of have in handy, or just have sort of in the back of your mind, because they come in handy when programming. Now finally, you have loops. This is another thing that's really useful for you, that makes lists even more useful, is that we can loop over lists. So loops will repeat code, and they are often used with lists, as I mentioned. So here we have a shopping list: eggs, ham, cheese, and onions. We can use this 4 item in shopping list, right? And this, keep in mind, this item can be anything. It's whatever variable we name it is going to be the name of that. It's going to be a variable that we can use in our code. So this is going to go over every single item in the shopping list. So this is going to print eggs, and it's going to print ham, it's going to print cheese, and it's going to print onions. All right, and so we have we have while loops as well, where we can start with some variable, but we can basically, as long as some condition is true, we run this code and we keep repeating it. So we can do a while I is less than 5, and we can start I at 0, and we just keep adding 1, right? This is going to run 5 times. And then one thing to kind of sort of note is that every for loop can be described in terms of a while loop. They're very similar, but for loops are better for lists and collections, right? And while loops are kind of better for some kind of program logic and stuff like that. We are going to use a while loop for our game later. So quick question number 2. So for another 10 points, how many times does waiting, how many times does waiting get printed? So we have our traffic lights, we have red, red, green, red, green. And so for every light in our traffic lights, if it's red, wait, otherwise we go. So let's think. So it seems, okay, we're starting to get a few respondents in there. We'll give it a few more minutes. About half of you have responded already. Good job. All right. So red, red, green, red, green. Okay, so we're up about 70% of people have responded. So we're gonna walk through this answer here quickly. So let's just, we're just gonna walk through it. So for every light, we start at the 0th light, and we see that it's red, so we're gonna print waiting. So that's 1, right? We start at the first red. It's red, so we're gonna print waiting. So we have 2, right? Green, well, that's not red, so we don't do anything, or we print go, so that's not gonna print waiting. Now we see another red, right? And so basically, essentially, it's just counting how many reds are in the list. So you're right if you said 3. Let's see. Okay, functions. So now we're on to sort of functions. I don't know if you went over this in your beginner sessions or not, but so we're going to go over these quickly. So functions allow us to sort of package sort of blocks of code into sort of these very they're not necessarily condensed, but they're like their own little ecosystems. They're their own sort of programs that you can kind of call on, right? You can pass things into. So you can reuse this code sort of whenever, however you want, right? You can, and so using functions is really useful for a lot of things because it allows us to cut back on a lot of code reuse. If you end up if you find that you're writing the same amount of code, like the same 3 lines of code, like 10 times in your project, it becomes very difficult if you have to modify 1 line, right? So it's better to just put all of that code inside one function, and then you can call that function anywhere in your code, and you only have to worry about any edits and things like that. You only have to worry about doing that in one spot. So so I mentioned we call a function. That's just the way that's just the convention. When we say call a function, that means we're passing sort of argument into the function and we're running the code inside of it. So that's what call means. So here's a quick preview. So this is sort of what they're going to look like. So we start in Python, at least. So we start with this define, so def, right? We define a function using def. And then we have to give it a name. It can be whatever, any name we want, as long as it's not another keyword. So you can't name a function like while, because Python's going to think you want to put it in a while loop, right? Just give it a reasonable name, and then any parameters you want. And so these parameters, it can be empty. You can have functions that have no values. And then you can also have functions that take in multiple values. Like, so you have like an X and a Y. And if you want to have multiple values, you would put in a comma in between. You would just put commas in between all your values. And then what this function body is this is the code that we're putting inside. So this is the actual code, right? that this function is going to do. And then finally, we have this thing called a return value. In Python, we have to use the return sort of word. We put return, and then we type in the value we want to return after that. This is optional. It is completely possible for functions not to return anything. So we could just completely omit the return statement and it'll be fine. But if we do not have a return statement, then the function cannot put things out, cannot move things out, right? So let's look into an example. This is a function that adds two numbers together, right? So it takes in two parameters, A and B. Notice they're comma separated. We add, we give it a name. We give it a name that's relevant to what it does. And then we sort of take our sum, A plus B, and then we return the sum, right? So you have to use the return keyword. And so now we've made our function. We want to use it in our code. It's time to call it. So it can be called anywhere. So inside add, we have sort of variables internally. So with this add function, we have an A variable and a V variable. Spaces between, you don't have to. It just makes your code more readable. You don't have to put spaces. You can put them sort of in like right next to each other, but putting them way too close to each other makes it really difficult to read sometimes. So if you have a ton of different operations, it becomes very difficult to check like what's going on. So it just kind of depends on what you want and who do you think could be reading your code. So back to functions. So inside the function, A is a specific variable inside the function and B is a specific variable inside the function, right? So neither A or B, if I pass in this 3 and this 5 into our function, this add is given the value of 3 and this A is given the value of 3 and this B is given the value of 5, right? So it's the values are kind of copied almost, right? And then so we take our sum and we add A and B to it. We add A and B and we put that into the sum and then return this sum variable that we defined in our function, right? And then this sum variable is only available inside add. Once add returns it, or once add ends, sum no longer exists. So we can't use sum outside of that function, right? So the key takeaway is just when we want to use a function, we want to make sure we have a return statement if we need one. And then when we pass data in, you want to make sure that we use that data and then, return if we need to. And then if we want to get data out of a function, we have this value equals, we can assign anything that comes out of it from a return. And then, as I said, when we want to pass things in, we have to use these commas, just like how we defined it, right? So this is how we define the function, what's going to be passed in. This is how we're going to call the function. So you need to put the name and then parentheses. So if you notice, we've already been using print. Print is a function. The length is a function, right? So it passes in takes a list. And so we're going to move on to tuples now. And tuples are used to store multiple items in a single variable. They're very similar to lists, but there's a caveat in the sense that once they're created, we cannot change tuples. So for example, we have my tuple. We use round brackets, 1, 2, and 3. And we can index them just like a list. So we can print this is maybe a 0th element or 1, and we cannot, as mentioned, we cannot change them. So once I define a tuple, it's defined like that forever. I can't change variables however I want inside the tuple, right? I can only sort of read elements from it. I can't actually like write anything into it. And also you can't add additional elements. So if I have a tuple of 3 variables, like, right, I can't add a 4th element onto it. That's going to cause an error. There's no append method for tuples, right? So tuples are used commonly in Pygame. Tuples are faster than lists to create, and they're also good for storing data that isn't going to change. Like for RGB, you can define like a constant, right? Like white is going to be some red, green, and blue value, right? And so you can just put that into a tuple because that's not going to change, right? Because the color white doesn't change. So we're going to do a quick exercise using tuples. This is the first exercise. We're going to go into breakout rooms. You can talk with your mentors. So we're gonna write some code, and you're gonna find and print the smallest x coordinate in a list of coordinates. So this is an example. You can come up with your own examples. Your mentors might give you something. So an example of, yeah, so this is going to be an example of that. So basically what you want to do is you want to find the smallest x coordinate. So the first element is going to be our x, second one's going to be our y, which, you want to basically print out the smallest x coordinate. So that's going to be 18 in this example, right? If you want to challenge, maybe try doing it with the y as well, right? So if you can find, so if in this case 5 is going to be our smallest y. So just go ahead. It's going to use everything that we've already learned up to this point, and so see what you can do with that. I think AJ will move you into your groups now, and then we'll go over the solution in a little bit. Let's see, people are starting to move.
Hey, how much time did you allocate for this again?
Me?
Yes,
Oh,
yeah.
Oh, for this? I don't think it's going to take too long. I'm assuming like 5 to 10 minutes.
Okay, so should I close it at like at 6:30?
Yeah. That
Okay.
seems good.
Yeah,
'Cause
just probably
it's,
go in and check like right before the. Like,
yeah, it's
done.
because it's just like a for loop and an if statement and things like that, and it's just kind
The
of.
thing is, we had like a few people here that weren't there yesterday, so they might need to set up.
Oh yeah, that's true. That's true.
But at
So
the end of the day, it depends on if you can like cover everything on time or not. So
yeah,
what do you think?
yeah.
Is reasonable?
I mean, if they missed the last session and they don't have the whole Python stuff, there's not much I can do, because like if I were to go back and show everybody how to install that, it's going to take like another.
Oh, no,
10,
that's
20 minutes.
fine. But like, what's the maximum amount of time you can give for this exercise, I guess, to still finish at 7:30?
8 is fine. Once you get to 6:30, I can start working through it. I think I took a little too long on the functions, but
Okay, sounds good. Yeah, I'll close this.
Yeah. Yeah, and then I might go through the different breakout rooms, and if I
Yeah.
find that they've already solved it and it's going quickly, we'll just bring them back.
Okay, sounds good. Perfect.
Is there anything you need me to do, or do I just chill?
I don't think so, Ishan. I mean, I could. Is your role just to like collect the what's it called, the poll answers and all that?
I believe so. To be honest, my engagement commissioner, that term is kind of used loosely.
Okay, because the engagement commissioner, it comes under VP comms. So Pooja would be like, did Pooja like assign you any task or anything?
No, she just said like the only thing she said for sure is the after discussion. I forget what it's called.
Oh, like the debrief session?
Yeah.
Okay. Did she want you to like write some notes on that, or like is there something specifically you have to do for that?
No, not that she told me about, unless you want me to do something along those lines.
No, I mean, you could always just stay for those for that session, so you don't have to stay for the entire meeting. Instead, you could just hop by like you could stop by at 7:30 and just attend the debrief session, see what's going on there. And my guess is she kind of wants to know how each session went. So if you're present for those meetings, you could like relay on the message to Pooja about how the session went.
Okay, and then I'll just get the Ignite points from you then as well.
Yeah, I'll send them to you today.
Okay, sounds good. Then I'll probably just head out.
Okay. Darcy, I assigned you to breakout room 4. You could go ahead and join that. We're just working on some exercises here. Mentor will get you up to date. I believe I opened the room for you, so you should be good to go.
Yeah, we got a bit more people this time.
Yeah, my guess would be that like our session 0 maybe wasn't marketed properly, so like people didn't attend because of that. I'm not too sure why, but
Yeah.
yeah, I'm glad there's more people today.
It's good. I might just go by and then check how people are doing in the next 2
Okay.
minutes.
Okay, sounds good, man. Yeah. Oh, do you want me to put you in a breakout room? I think you wanna do it.
Because it says it recording. If I go into the breakout room, will because I'm co-host, will it still be recording?
No, no, you're good. It's just gonna record in the main room.
Okay, I was just curious about that. Awesome.
Darcy, are you still there? Yeah, no, we put you into breakout room 4. We're just working on an exercise. You are a little bit late. You might have missed like most of it, but Aaron will be going over it once they get back from breakout rooms. But if you want to join room 4 right now, that should be good. So if you hit the breakout room button on the very bottom of your screen, you should be able to join. Are you able to see the button? Hello?
I'm sorry, I didn't realize I was muted. I was just saying that I was checking how many people are in here. It looks like we're good to go. I'm going to start going through the solution really quickly. I have sort of the thing for my keys. Okay, this is here. Okay, so there's a few different ways you can go over how to solve this. I'm going to do the sort of simplest way. Why is this? That is very odd. I'm having some. Oh, I see. Okay, it's just delayed. I think it's just because I'm screen sharing and it's a big screen. So give me. There we go. Yeah, okay, it's working now. So the first thing we want to think about is, well, we want to loop through this. So we're going to use a for loop. So I'm going to do for coordinates in and this little colon there. And then you want to do a check here. So you want to check our x. So our x is going to be our 0th element. And we want to check if it is less than something. So what I'm going to do is I'm going to set a variable. It's going to be called a minimum. And I'm going to set it to some really, really, really big number. Right. And then I'm going to check if our coordinates is less than this really, really big number, which it's going to be. Then I'm going to say that our new minimum is going to be equal to this x variable, right? And then right at the end, I'm going to print. So yeah, so essentially what we're doing is we have this sort of 1 billion, whatever that is. We check, okay, this is 22, much smaller than a million. So that's going to be our next smallest. We check the next element, 38 is not smaller. So it's our minimum is still going to be 22. Next, we're going to we're going to check 18. 18 is smaller than 22. 18 is our new minimum. We go check 96. 96 is bigger than 18, so we don't do anything. And then when we finish, 18 is going to be our minimum. So that's going to be the solution there. If I run this, Python 3, and then I think it should be py, this should print 18. Or not. Oh, I didn't save it, that's why. That should work. Yeah, I saved it, and then I'm gonna run it really quickly. It should print 18. There's sort of, that's sort of the way to do it. There's actually, I mentioned this earlier, someone mentioned about doing it quickly. There's actually a fun way you can do it in one line using this minimum function in Python. So Python actually comes built in with this minimum function, which minimum, essentially what minimum does is it does this check for us. So we could actually replace this check with minimum equals min of minimum and our x. Right, and you can delete these two lines. And then these two should print the same thing. Yeah, 18. Or, yeah, it should print 18 twice. 18 and then 18 and 5. Yeah. So that's another way. This minimum function can come in handy when you're actually doing programming. There's also a max function as well, which does pretty much the exact same thing. I didn't expect you guys to know this, but the way you were intended to do it is with that if. But that's just keep that in mind. It might come in handy for your next exercise. So we're going to come back into our slideshow. How does it take the minimum of two numbers? It checks the first element. That's what it does. Yeah, it's a bit fancy, but the way it works is when you have tuples, the way tuples are ordered is it's ordered by the first element. And if you have two tuples with the same first element, it checks their second element. And if their second element is the same, it checks the third. If there's no third, then it doesn't do anything. So it's a bit a little bit more complicated, but that is, you can order tuples that way, and that's how Python internally will order tuples. But yeah. Yeah, no problem. Let's just move on really quickly here. So dot operator, this is going to be really important for everything we're going to be learning after this, because it's really important in object-oriented programming. Dot operator is used to call functions for these things called objects. So we've used it with lists before. That append and that remove, those are functions that we call with the dot operator. And these functions have a special name. They're called methods. So this is not the append function, this is the append method. So we're calling this append method, and it's going to add milk to the shopping list. And we have this remove, which is going to do the opposite. It's going to take away cheese, right? So each of these uses the dot operator to call a function on this list. And you can define your own. We'll do that much later, but we'll be using a lot of these dot functions defined in sort of Pygame. So they can be chained. Yeah, so sometimes objects will have other objects in them. For example, we want to move a dot object, we take the dog and we dot, we get the left front paw, dot move. The way you can kind of think of that dot is like you're grabbing something from an object. So in this case, the dog, we're grabbing its left front paw and we're going to move it, right? And the dog, we're going to grab its right front paw and then we're going to move it. So it's kind of this, it's like in English, you have this subject, or you have this object or subject verb object, right? So you have the subject, dog's right front paw, and then the verb move. And then the object is going to be whatever we're going to pass in there. So this could be like an XY. It could be subject verb object, dog's right front paw, move it to this position. That's you kind of think of it almost like an English sentence. So you need to make sure you call the right move function using dot operators. You want to make sure you have the right sort of things you're calling. So Pygame uses this a lot. So we're going to use this thing called Pygame init, pygame.image.load. We're going to see a lot of examples very, very soon. So this is where we get into Pygame. And so there are some files. So we have this template file called main copy and rename.py, which you're going to, as the name implies, you're going to copy it and rename it. So there's a link here to our GitHub. I don't think I can copy it right from the slides, but if I go back, yeah, there's going to be, I don't know if someone can post that in the chat. Actually, yeah, I'm going to copy paste it here. So this is going to be the file. And then you want to come down, you want to see where it says copy the file, main copy rename. You're going to copy that and then you're going to rename it something in your code. So there you go. Yeah, so you want to rename it something. I renamed it main.py. They recommend renaming it main.py. You can rename it to anything you want, but just keep in mind that when you call it, you need to call it by that name that you named it. So we're just using main.py as a reference. So this is where we split these into different sections. We're going to talk about sort of Pygame. So there's going to be some pre-written code inside of it. If you don't know what you're doing, it says don't touch it, don't worry about it. It'll make more sense as we kind of go through these things. These are just kind of what's called boilerplate. It's just a bunch of code that's already been written to get to get all the initial steps finished so you can start writing some code. So this is where you prepare everything. You do pygame.init, and this init you can kind of think as saying initialize. So remember this subject verb object syntax. Pygame initialize, we're initializing Pygame, required for all Pygame modules to work. So here we're going to have a clock. So we're going to take a Pygame time, and we're going to create a clock. This is going to create a clock object. And then we can use this to control its frame rate, which we're going to do later. So we want to draw a screen. So we're going to give it a screen size and a screen height. And so there's a convention in Python where if you create a variable in what's called screaming snake case, so all capitals with sort of underscores as spaces, then it's a constant. So it's going to, it basically is telling other programmers, don't change this variable. I don't want it to change. This is going to be defined right at the start. So the screen width, screen height. You can change this to whatever you want if you wanted to, but this 1000 by 800 is pretty much fine. So then we're going to create a new window. Screen is going to be pygame.display set mode, and then you can pass in the screen at width and the height as a tuple, right? You can pass that in as a tuple, and this is going to create the window, right? So, what is it not working? And now we have this event section where we're going to actually cover what are called events. So this is how Pygame handles, or another game engines handle user input, like moving your mouse, pressing keys on the keyboard, pressing the mouse button, right? Things like that. Or this is how it's going to handle these events. So there's events we're going to deal with later, as I said, but there's a few events we kind of need to think about, and that's the quit event. We'll get into that later. But so this is where we kind of go back into this while loop that I mentioned earlier. We need to set this while true, because a while true loop is always going to be looping. It's kind of like, it's pretty much an infinite loop. It's going to just keep looping forever. And this is how we can get our program to kind of keep running in the background. Because if we don't have this while true loop, it's going to run once, it's going to open a window, and it's going to close. So we need to have this while true so that the window is always open, right? So this is where we change variables, other logic runs. So all of our game logic that we want to happen in the game is going to happen inside this while loop. You can every frame. So what we're saying is for every frame, we're going to run this code, right? So that's kind of how that's going to work. This is going to be our draw set. So this is where we're going to start going into drawing things on the screen. So when we defined our screen, so if you remember, we go back here, this screen, we do Pygame display set mode. We've already set the width and the height for our screen. So we're going to call a method on our screen, which is going to fill it to black. So screen fill black, right? And then all the draw code is going to go after that. And then so we're going to flip the display. That just flips the Y and the X axis, because the way game engines work is positive Y goes downwards, not up. So this just flips it, so it's more intuitive. And then we're going to click by some frame rate. So there's a constant in the file which is set for 60 frames per second, right? So, and in any code here is going to be ignored. And so this is where we're going to start getting into sort of drawing. So you can fill it with any color. The black is just a constant tuple that's defined earlier in the code, but it can technically be anything. So if you go to a place like Color Picker on Google, you can pick any color you want that you like, and you can just copy in these 3 integers and put those in a tuple. So this is good. We're going to get into setting up your first rectangle. So a rectangle is going to be an object, a box that stores information about where and how big a rectangle should be. So yeah, it doesn't draw a rectangle. It just creates a rectangle object, and the rectangle object holds information about that rectangle. So it's going to hold information about its position, going to hold that information about like how wide it is. It's just you kind of think about it almost as like a tuple, or like just a list of different sort of things inside of it. But we need to draw the rectangle, and to do that, we got to call this rectangle method on draw, or the rectangle function inside draw. And inside here, this is where we're going to do the drawing. We need to pass in the screen we want to draw on, the color, and the rectangle we want to draw. And so this is how we define it. We're going to start creating our rectangle. It's going to be pygame.rectangle 50, 100. This is the position of the top left corner. Okay, it's going to be the top left-hand corner. And then we want to give it the width and the height. And the width and the height is going to be how far in to the right we want this to go, and how far down we want this to go. So as you can see, this is 50, 100 right here, top left corner. And then this is going to say, okay, 100 plus 200 is going to be 300. Then 50 plus 150 is going to be 200. And it's going to draw our rectangle right here, right? And then we give it this color, which is going to be 255, 0, 0. You can also color to anything you want. And then you want to call this method to draw the rectangle on the screen. You can also change the position by, explicitly sort of grabbing and changing variables using sort of the dot operator. And we got a good amount of time now. So the next little bit is going to be on the next exercise, and that's going to be on drawing the rectangle. But before that, I'm going to just hop into an example where I'm going to show you how to draw. And I'm just going to cover everything that I already did, but in code, right? So this is going to be live coding lessons. What is it? Here's this MAIN.PY. So I'm just going to get out of this one. Okay, so if you look, this is the, going down. This is the file. This is going to be exactly the same as what you copied, right? Or what you should have copied. And this is going to be our while loop. So this is where we handle this event. You don't need to worry about this yet. This just basically says when we press the X button, we're going to close it. This is going to be other keyboard events that we don't need to worry about for now. Mouse events, don't need to think about any of this. All we want to do is think about drawing, right? So we want to draw after we fill the screen. But first we want to create a rectangle to draw. So that's what I'm going to do. I'm just going to say, okay, we're going to have our rectangle, and this is going to be Pygame dot rect for rectangle, and then I'm going to give it how wide is the screen? Just it's 1000 by 800. So I'm going to say, okay, I want this to be, where did I go? 500 or 250, and then I don't know, 250. Just kind of sort of somewhere in the middle. And then I want it to be sort of 300 pixels wide, and then maybe 200 pixels tall, right? So that's going to create our rectangle. And then I'm just going to color it white. And then mouse events. So here, after we fill the screen black, okay, we'll go Pygame dot draw, and then I'm going to call rect, and then I'm going to give it the screen. I think it's called screen, and then just going to give it white. So I'm just color it white. You can color it. You can just color whatever color you want, and then I'm going to give it this rectangle. Right. So this should work. Let's save it. And I should probably run it on Y. And this is going to open a window somewhere. Might not open it here. Slowly should open it somewhere on. It's running. It takes. I think it takes a while. It's probably because I'm also screen sharing. But this should show up somewhere in the bottom here later. But if window should appear, and in that window you should see a white box or whatever color and wherever you placed it, however wide it is. It's going to look a lot like it did on the slides. I'm just going to exit and then try this again. Okay, see, hello from the Pygame community, and then this should start. See, it opens a thing. Okay, there we go. There's a window. I just had to run it again. So yeah, I just drew a box. And so that is that simple for the most part for now. If you want to move the box, which is what I'm going to do now, I'm just going to move the box to the right. So what I'm going to do is I'm going to set some I variable, I equals 0, right? And then at the end of our while loop, I am going to, just going to go right here. I'm going to add 1 to our I variable. And then I'm going to basically, I'm going to just draw, or not draw, sorry. I want to take our rectangle, and then I'm going to take its X value, and its X value is I'm going to add 1 to it. So I probably don't actually need this I. yeah, so I'm just gonna add 1. And I might actually add more because 1 is kind of small because this is gonna increase, this is gonna cause it to move to the right 1 pixel. So I'm gonna say 10 pixels. So it's gonna move pretty quick. But you're gonna see that I grab the X value, I move it to the right, and then I'm going to, it's slow. Give it a moment. It should run. I think I broke it here. Rectangle X should move 10. I think 10 might be too slow. Oh, and you see it starts moving. And so obviously there's no collision, but all it does is every loop is going to move the pixel 10 or move the rectangle 10 pixels and then redraw it. Move it 10 pixels, redraw it. Move it 10 pixels and redraw it. And if I wanted to move it, let's say I wanted to move it in a straight line, I'm going to add, I'm going to add something to the Y value. So this is going to be 3, right? Just so it's slightly moved. Actually, I'm going to make it move a little faster. I'm going to make it move, 5. 5 is good. So this should make it move in a diagonal line now, right? So it's going to move diagonally. Or I guess not. Maybe I need to add it correctly. I might not have saved it before running it. Yeah, there you go. I just have to redo it. So as you see, it moves it diagonally in a straight line. And so that's just kind of what you're going to be doing in this next exercise. I just realized I gave the answer, didn't I? But yeah, let's make it move around. Make it move around and then make it bounce off the screen. That's going to be the exercise. See if you can get it to bounce off the screen. And that's going to require you to use some of these variables like the X and the Y and the height. And then, yeah, so we'll change up the exercise so that the bonus is now the new exercise. You got 30 minutes to do that. This is going to require you to kind of really think about some of the logic, and it's very easy to run into a few bugs. So very quickly, I'll show you something I did too. So exercises, I think I'll show you something I did last night, just in preparation. So there's let's see if it'll take us a few minutes. Oh, there it is. Here it is. It should draw, and then here we go. So this is a rectangle, and it's as you can see, it kind of bounces around the screen. I should be able to grab it. Oops. There we go. I can grab it. And so the color of the rectangle, yeah, I don't know if the quality is very good on Zoom, but the color of the rectangle is based on its speed. So the faster it's moving, it's going to be red, and when it's not moving, it's going to be green. And as it's moving, it's going to be anything in between there. And I can sort of bounce it around. It's going to bounce around the stuff. And you can see that I have some dampening. So there's like a little air resistance, and it's slowly going to get slower and slower and slower. It's also affected by gravity. If I let it drop, it's going to fall. If you want to challenge, do the bonus, see if you can get it to bounce around the screen like this. If you want, you can maybe even try adding some gravity, some physics, and things like that. So we're going to put you into breakout rooms now. And yeah, good luck with that. I brain farted and gave you the answer for the exercise, but that's okay. Yeah, so let's go ahead and do that. And yeah. All right. See, everyone's moving. That's good. Yeah, that's good. I think Darcy's missing here. Yeah,
James, sorry, James, are you able to open up the breakout rooms? I believe I assigned you to, let's see. Breakout room 3, so you should be good to go.